Okay, in this video we're going to talk about using the power rule for derivatives, differentiation that's called, okay? Power rule is pretty straightforward. It's actually the easiest of all the rules, and you can't really do many of the other rules if you don't know the power rule. So, this is pretty straightforward, like I said, but just in case you have trouble with it, this is a resource for you to watch, okay? So I'm going to go over 3 examples for using the power rule. It's used for taking derivatives of polynomials primarily, so just try to follow along if you're watching, and I appreciate this, okay? So, in this question, we have this polynomial here. This is a 4th order polynomial. We're going to take a derivative of this, okay? So, the process is very straightforward. I'm going to change my color here, and we'll go through this. So, okay, my derivative, f prime of x, what we're going to do is we're going to multiply the coefficient of every term by the exponent. So, we're going to multiply these together. So, 3 times 4 will be 12. And then I'm going to take 1 away from this exponent. So it's going to be x to the power of 3. This process is continued straight on all the way through. So we're going to keep doing this. It's going to be 3 times 6, negative 6 rather, so it's going to be negative 18. X to the power of 2, 2 times 2, which is 4. X to the power of 1, that's a 1 times a negative 1 here. So that's going to be minus 1. If I take 1 off this power, it becomes 0. So this will be nothing, okay? Or it would be 1 really. So that's why. So it's 1 times negative 1. So anything to the power of 0 is 1. So this is 1 times negative 1, which is now negative 1. That's what we have there. Okay? The derivative of a number is always 0. And the reason for that is when I say 6, it's really 6 times 1, which is the same thing as x to the power of 0. So if I end up multiplying 0 times 6, that's nothing. So the derivative of a constant or any sort of number is 0. We'll just understand that. So this is your answer. This is your derivative right here. Okay, that's all there is to it, really. Okay, it gets a little more complicated with some fractional exponents. We're going to do another question that's going to have that in it. So this is what we're going to do here. Okay, so in this question, we're going to do this one. This one's got fractional exponents. So we're going to say f prime of x rather, is equal to this coefficient times this exponent. 3/4 times 4 is going to be 3. It's going to be x. We're going to take 1 away from this power, which is the same thing as subtracting 4 over 4. That's identical to 1. So if I take that away, I'm going to get a negative exponent, negative 1/4. I mean, we can leave it like that for now. There's another way to write this, but we're going to leave it like this for the time being. So we're going to say 1/2 times 6, right, is going to be 3. Take 1 from this power, right, and 1 is the same thing as 2 over 2 in this case, which is going to be x to the power of negative 1/2, right? And then the derivative of a constant, as we well know, is 0. So this is your answer. You could write it like that. Okay. Another thing you could do is rewrite this if you understand negative exponents are actually fractions. Okay. So we can write it this way. This is from algebra, but we can write this as being 3 over x to the power of a 4th. So if it's a negative exponent, it's going to go to the bottom and become positive. That's what's going to happen, right, on this fraction. Plus 3 over x to the power of a 1/2. You could write it this way, right? And if you understand what fractional exponents are, they are actually roots, okay? So you can also write this way. There's lots of different ways you can approach this, right? And they're all equivalent. They're all the same thing. So this could be written as 3 over the 4th root of x plus 3 over the square root of x. Because x to the power of 1/2 is a square root, and x to the power of a 4th is a 4th root. So you can write this answer like this as well. So all of these actually are technically correct, all right? But ordinarily, I would either just take this one or this one. And, I mean, I would take any of them, honestly. But just pick one you like, and that's perfectly fine. Ordinarily, in most IB situations, that won't matter a whole lot how you write your answer. They should give you credit for either one. So we're going to move on to the next question. This will be our final question in this series here. This is just the power rule. This is all I'm talking about. So this one here is a product of 2 binomials, right? So for the power rule, if we're going to use the power rule, we actually have to multiply those binomials out first. If we don't multiply the binomials first, we can use the product rule because it's a product of 2 binomials. But you can get the same answer multiple ways. So I'm actually just going to multiply these through first, and then I'll use the power rule instead of using the product rule. Alright, so I'm going to multiply these out first. So I'm going to say, okay, I'm going to FOIL this, is what we say in algebra, which is terrible. It's called the distributive method because foiling I don't like, but we'll do this. 2x times 2x, we'll call that 4x squared. 2x times 1, which is 2x, negative 3 times 2x, which is negative 6x, and negative 3 times 1, which is negative 3. Okay? So we're going to combine like terms. So this is actually equal to 4x squared minus 4x. We combine these two terms, minus 3. So now we can actually take the derivative from that. So the derivative of that function that I have right here will be 2 times 4, which is 8, x to the power of 1, minus 4, right? Because this is now going to be the power of 0. The derivative of negative 3 is 0, so this answer is 8x minus 4. You can write that as, call it 8x minus 4 without that exponent, okay? So this is your answer, and that's it, okay? Very straightforward. And I hope that was helpful, okay? We're going to go over more rules in other videos. Please watch other videos because they're going to be helpful to you, I think. And thanks for watching.